Welcome to Null Design channel. In today's tutorial I will show you how to create an echo-mind animation design concept in Cinema 4D, just like the one you are seeing now. We'll dive into constructing the scene geometry from the ground up, using Boole and Remesh objects, along with some extra practical modeling tips. Then, using the final geometry and the power of MoGraph, you will learn how to animate it quickly and easily. Let's jump right in. My starting scene is based on the geometry of an upper human body, which I named Geo, and includes a few cameras set at different angles for easier navigation in the viewport. First, place a cylinder in the middle of the head of our Geo, then add tube objects to create the structure as shown. Next, add a second cylinder object with a radius equal to the outer radius of the largest tube object you added. Make sure all cylinders and tube objects have a high number of rotation segments. This will help give our future geometry objects smooth edges. Also, ensure that all cylinders and tube objects are protruding from both sides of the Geo. To proceed, add a MoInstance object and drag and drop Geo into its reference object field. The MoInstance object helps us create copies of Geo while maintaining a connection to the original geometry. This is especially useful for non-destructive duplication, memory efficiency, and improving overall scene performance. Duplicate the MoInstance object multiple times, placing one under each cylinder and tube object in the scene. Now let's focus on creating the geometry object based on tube 2. Parent it together with the copy of the instance object to the Boole object. For the current part of the geometry we are working on, set the Boolean type of the Boole object to A intersect B. Make the Boole editable. Based on the resulting geometry, keep only the caps and rename it to caps2 for easier navigation. The current caps2 topology is unusable. We need to fix it to match the state shown in the reference image. The main rule we have to follow is that the caps topology must have clean, full quad polygon loops along the edges. By following this rule, we will be able to apply a bevel to the geometry's edges without any artifacts later in the tutorial. Let's fix the caps2 topology to make it usable. Parent it to the Remesh object. The default Remesh settings already give us a good result, but we still don't get clean, full quad polygon loops along each edge. To solve this, try increasing the mesh density value to 200%. All seems to be working properly now. In certain cases, this method isn't entirely effective, so you will need to use other modeling tools and techniques to achieve the same result. Apply another Remesh modifier above using its default settings. This will help relax the current geometry's topology. Make the top Remesh object editable and rename the resulting geometry to caps2. Now it's time to connect its two separated caps by creating a surface between them. We can use the bridge tool for this, but due to the irregular point count on the inner and outer edges of the two caps, the resulting surface may contain triangles. This is undesirable, as it can cause artifacts when a bevel deformer is applied later on. Moreover, the newly created surface may appear slightly twisted. We can use a somewhat different approach to resolve this. Make sure the Move tool is active, then select the edge loops of the front cap geometry. While holding Ctrl and the left mouse button, drag and drop to create the edge extrusion in the global z-axis direction toward the second cap as demonstrated. Immediately after, switch to the Scale tool and while holding Shift, scale it down to 0%, using the global z-axis as a guide. This will help straighten the extruded edges. Repeat the same process for the second cap, leaving a small gap between all newly created edges, as shown. Now use the Bridge tool to connect the inner surface gap first, followed by the outer gap. In some cases, especially with dense geometry, the Bridge tool may not be able to connect all selected edges at once. If that happens, try bridging smaller arcs of edge segments, for example 30-degree sectors. Next, use the Loop Pass Cut tool to add loop cuts to the newly created external and internal surfaces to increase the polygon density of the geometry. The first geometry object is ready. Rename it to Object 2, then apply a bevel deformer to it using your preferred parameters. The resulting edge bevels look perfect, with no artifacts, thanks to our careful prior geometry preparation. Use the same method to create all remaining geometry objects. As a result, you will get something similar to what is being demonstrated to you now. It's time to animate the resulting geometry. Parent the first 6 geometry objects to a fracture. Add the formula and shader effectors to the scene and rename them as shown. These effectors will help us animate the geometric objects located inside the fracture. The shader effector will control the rotation animation, while the formula effector will control a wavy movement. You can experiment with the two effectors settings on your own or follow the demonstrated settings to achieve a similar result. Make sure the effectors are listed in the effectors field of the fracture object. If they are not, drag and drop them there so the animation is correctly applied, otherwise the animation won't work. Press the play button. The animation already looks cool, but we need to fix one thing. The rotation animation appears the same across all geometry objects. To fix this, use the axis center tool to center the axis of each geometry object located inside the fracture. Then parent each geometry object to its own null. After that, use the enable axis modification tool to move the axis of the geometry objects apart. The greater the distance between the axes, the more random the rotation animation will appear. Play the animation once again. Now the rotation of each geometry object is more random and the animation behaves as intended. That's it for today, all the best and see you in the next tutorial!